Hello everyone, we are Math Easy. Today we want to present to you about our question. There are two types of ODE, which is first ODE and second ODE. Both ODE can be used in real life situations, such as in our question. The first question is about rocket launching estimation. For using first ODE, separable, and the second one is using second ODE, which is homogeneous, using the constant coefficient, is about car suspension system. So the first question, which is about rocket launching estimation, the The question is, a rocket starts its launch with 64 tons of fuel. The rate at which the rocket consumes fuel is proportional to the amount of fuel remaining, with a proportionally constant k equal to 0.1733 hours. So the first question asks to write the ODE equation. We write it dm over dt, which is the rate, equal to negative k, which is the constant, and mt equal to the rocket consumed fuel. So k equal to 0.1733 from the question, and m initial, which is 64. So the second question, we need to solve the ODE. We first separate m and t, and we substitute k equal to 0.1733 into the equation, and then we integrate both sides. We will get ln m equal to negative 0.1733t plus c, and then we dissipate the ln to make the m alone, and we get the m equal to c e the power of negative 0.1733t, and then we substitute c with 64, and we got m equal to 64 e to power of negative 0.1733t. And then we the next question is, how much fuel remains after 8 hours of flight. We substitute 8 into the t, and we will got 60 tons into the for the fuels. And then d, how long will it takes for the rocket's fuel to decrease to 8 tons? We substitute 8 tons into the m, and we will get t equal to 12 hours. For more information about this question, you can scan the QR code.
We look at an example for second ODE. So the question is, a car suspension system has a mass of 1000 kilograms, a spring constant of 16,000 Newton over meters, and is critically damped with damping coefficient. Write the differential equation modeling the vertical displacement in meters of the car body at time in seconds. So the equation is m d2y over dt square plus c dy over dt plus ky equals to 0. So it's the given the mass of 1000 kg and the spring constant of 16,000 Newton per meters. So since we got the differential equation, then we find the value for c, which is critical damping. So we have the c square minus 4mk equals to 0. So we substitute the value of m and k. Then we will get 8,000 Newton second per meter. So for the next question, given the initial displacement y equals to 0.1 meters, compress 10 centimeters, and initial velocity of 0. Solve the differential equation to find yt. So we use the equation of mr square plus cr plus k equals to 0. Then we use the r as subject, and then we reorganize the equation, and then we use the yt equals to a plus bt exponent negative 4t. So given the initial displacement equals to 0.1 meter, so we know that our amplitude will be 0.1 meter also. And since the velocity is equals to 0, then displacement is velocity is the differential of displacement over time. So we differentiate, and then we got the velocity equation. Then at t equals to 0, we substitute the y equals to 0, or y prime equals to 0. Then we will get the equation of y time, which is displacement of time, the general equation. So for the last question, calculate the displacement y 0.5 after 0.5 seconds. So this means the displacements, we need to calculate the displacement during the time of 0.5 seconds. So we substitute the t, then we will get the displacements equals to 0.0406 meters or 4.06 centimeters. If you are wondering where do we get this equation and how do we relate to it, so you can scan the QR code on the top left. That is all from us. Thank you for watching.